Good morning. This is Bob Rapp, and it's April 22nd. Happy Earth Day, everybody. So I'm just taking you through my favorite entry point for Azure Machine Learning Studio, and that is called ml.azure.com. And when you go into that studio, there's really three different ways to interact, and we're going to look at each of those today. The first is automated ML. And if I think of the audience that I'm talking to today, some of you are analysts, so you're typically using tools and doing reports and trying to get some insight into the data. Some of you are data scientists, so you're used to the underlying algorithms and how they all work and compare. And some of you are working on the ingestion side, so you're bringing data in from lots of different sources, Databricks or Amazon or Google or Oracle or all kinds of places. So we're going to try to have a conversation that's interesting for all three of you today. And the nice thing about Azure Machine Learning Studio is if you're a data scientist, if you like to write code, if you like to work in Python notebooks and you're comfortable with Jupyter and all of that sort of thing, you'll be happy here. If you're brand new to data science and you just kind of have some data and don't know what to do with it, that's automated ML, so we'll help you there. And if it's kind of a between state, we have the designer, which is also called Machine Learning Studio, and I'm a huge fan of that because it takes probably millions of people years and puts it into some just easy to do stuff. So let's start with automated ML because it's the easiest to start with. And I've actually done some runs here so you could take a look at that. But I'm just going to start from scratch. And I'm going to take a data set that I have. I used to be a diabetic, so I'm having diet and exercise has changed that for me. But I'm going to select a sample database. And by the way, if you're not sure where to get data sets, we'll take a look at that too. So I'm going to go ahead and I'm working for a big network company. And I'm interested in BMI or body mass index. And then I've created a compute cluster. And what I think is going to happen is I'm going to predict some numeric values, so that's called regression. By the way, you guessed based on my data that regression was the thingy that I wanted to do. There's some additional configuration values that we could have. Okay, so if you knew the metrics that you wanted to use, and this is more for the data scientists, you could, but you don't have to. Okay. Also, if you wanted to look at how you wanted the features to look, you could change that. But again, since this is AutoML, we're just going to let the wizard decide. What's happening now is that it's going to look at the data, apply the algorithm that it thinks it should do, and then it's going to tell you how it did with the models. Okay, that's kind of cool. And so it's doing regression. It's using Spearman correlation, which again is one of the algorithms it could have used. And then it's going to start that run. Okay, so it says if we refresh it here that it's now running and it's preparing the Docker environment as we see here. It started on this time. It's using this compute target. By the way, that's just a virtual machine that I created by Bob. It gives me the training data ID and the output data sets, and it will just be running while we're talking here. So that's the first piece of the puzzle, and that's for people who just haven't really done anything with data science, but they're interested. Okay. The second one is a notebook. Okay, so this is for anybody that's comfortable with using Jupyter notebooks, and I'm going to go ahead and grab the samples here. And one of the samples that is interesting to look at, if I go down and look at these samples, is we have tutorials to create your first machine learning experiment. Okay, so we could start editing this notebook right away, and we can actually just go in and start using the data here and we're loading the diabetes, which is great. And we are going to and I just want to start editing this data, and we're going to clone this notebook. Okay, so it's going to merge the notebook that I had with the one that I'm cloning, and now everything that you'd expected to be able to do, you could do. It says, oh, we've got a kernel error here on the Jupyter notebook. So we're going to say, where do you want to run this? I'm going to run this here and figure out that error. And the other thing is, if I wanted to, I could edit it in Visual Studio Code, or I could edit it straight in Jupyter or Jupyter Labs if I wanted to, if you're more comfortable using that technology. So that's available to you now, just like you're used to using Jupyter. Here you go. And start running our experiments just the way we'd expect to do. Okay? Makes sense? So that's another way to do it. And then we're going to spend most of our time going up one level here. Oops. I'm going to leave that Jupyter notebook. And then I'm going to go back home. I'm going to spend most of the time in what I think you all came here to see today, which is Designer. And Designer is a very powerful drag and drop interface where we have started doing a ton of work for you. And I'm going to go ahead and show you some samples here. And if you think about machine learning and AI, we have things like letter recognition, parameter tuning, but probably the one that I see people want to do the most is regression. So I'm just loading a pre-built model. And then what I'm showing you here is that this is now a drag and drop of everything over here on the right. Okay, so if we take a look at automotive raw data, this is the raw, then we selected columns in the data set. We cleaned those columns if they were missing any values. We split the data into two different models here. So we have the training model, right, and the scoring model, and we want to evaluate how we did. By the way, we used boosted decision tree regression here because in this case we didn't have enough data for a good A/B test. And I can go edit each of these items, but I can also just submit this experiment as it is, and it says select the compute target, and I put one in here for you guys here for big network company, and I've said publish, and I'm going to call this test 99 here. And I'm going to actually, this gives us an endpoint to go look at later. So the interesting power of this is that all of the data sets that we can use, the sample databases, the custom models, and we also can create, and some of the folks I think on the call are already writing code in Python or R or text analytics or computer vision. And so all of these things turn out to live here in our pipeline. And so you see that I have one running right now. I completed one, and I completed one so we go take a look at run one and see what we did. So we did voting ensemble was the algorithm that we did. Did we give it any data guardrails? No. What happened with the model? And by the way, now if we look at the Spearman correlation, again, for the data scientists in the room, looking at the sample, what we see is that, and this is I think where we boosted the model, you can actually see that the more runs we did in this case, and running it with different algorithms, the algorithm that gave us the highest level of accuracy, still not a great model because we're looking for more like 0.97 or 98 or something, but again, the best model here is 0.64 with the data, and the worst model is 0.58. And actually, we ran a whole bunch of runs here, and the very worst that we did was robust scalar with elastic net, which is a -1, so not something you want to do. But we didn't have to figure out how to fit the data to the algorithm. It did it for us, and we have this all here. Now, the interesting thing is that now we could share this with the team and do this. We could split the jobs up. So we have our pipeline in Designer. We've got our register data sets, which we've put in here. Here's the experiments that we're running. We're just running one set of experiments with different data sets. Now we could create code to share with other people. We put it on GitHub or local files or whatever, so we could actually take the modules and share them. We could do a new pipeline, create a new model, and obviously have some endpoints. And then my compute is just something I've created here. That's just a G2 VM. Here's the data source I'm working with, and I think that we wanted to talk a little bit about how you would put Databricks and other data stores here. And we've got some data labeling and some link services. So with that, let's get to some questions and see how I can be helpful today. Okay?